Java threads, full lines indicates a running process, dotted lines indicates a waiting listening process, and horizontal dash lines indicate a wait for a return. In this figure we see how a new thread is spawned every time a call comes in Java remote method invocation. Now we are considering Java threads. In this diagram, the full lines indicates a running process. Dotted line indicates a waiting listening process, and horizontal dash line indicates wait and return. In this figure, we see how a new thread is spawned every time call comes in. Here you can see the algorithm here, a distributed recursive factorial here. In all its aspect, Java is an innovating language. For example, it introduces garbage collection in the industry, and on another note, we see how Java introduces a standard threading library compared this with C, which has all kind of dirty libraries and tricks like set jump, set JMP, and long JMP to solve multiple sessions. A thread is execution context which can run together with other threads in the same environment. The difference with processors is that threads do share memory while processors don't share memory. This is important because Java RMI has already seen wait before returning an answer. With Java RMI, client can ask the server to execute a method and return an answer. In the meantime, the client simply wait and now let's have a look at the Java programming algorithm here. The fact app here class exports the factcalc interface. The factcalc is an object that is able to calculate factorial of a certain number by multiplying that number by factorial of that number minus 1. To do this last step, the factcalc needs to be supplied another factcalc. This can be seen in the definition of fact method. When we start this application, it will first try to look up an existing factcalc. If there is one, it will contact that factcalc to calculate some factorial. If there's none, it will become a factcalc itself and announce it in the registry. To start this program, first the RMI registry should be started, and afterward two times the fact app, two times the fact app. The last fact app the factcalc 2 from now on request factcalc 1 to calculate the factorial of 3. In return, factcalc 1 will request the factcalc 2 here to calculate the factorial of 1. But how it is possible? How can the original request be interrupted while he is still waiting? The answer lies in the Java threading mechanism. Every time an RMI call comes in, server thread will spawn a new thread which handles the request. This can be seen in figure here. Here you can see FACCalcer1 here, RMI registry, and FACCalcer2 here. FACCalcer1 is connected to RMI registry through lookup, and RMI registry is connected to FACCalcer1 through not bound, and then FACCalcer1 is connected to RMI registry via bind, and RMI registry is connected to FACCalcer1 by bind OK. Then FACCalcer2 is connected to RMI registry via lookup, and RMI registry is connected to FACCalcer2 address, and then this is in a server skeleton area here. FACCalcer2 is connected to called the FAC3 accelerator 2, and then it came back to FAC2 accelerator 1, FACCalcer 1. Then it came back to FAC1 FACCalcer 2, then it went back to FACCalcer 0 FAC0 FACCalcer 1, and then 1 here, then 2 and 6, and then the FACCalcer 2 here. Now this is the end of my presentation. Thank you very much for watching it.